Hi guys, welcome once again. Oluwafe Mathematics on your screen. So today we'll be discussing on differentiation. Differentiation. So basically, what is the main concept on differentiation? So I'm just going to take you. You are jam students. So I'm just going to fast forwardly give you the key way on how to answer a question on that differentiation whenever I see a question on differentiation. So a differentiation question is going to look like this: y equals to ax to the power of n. This is the way it's going to look like. Now, differentiation is what? The y dx. That's as we fondly call it, the y dx. So if I am going to differentiate this, this is what it means: the y dx is equals to multiply a times this n, this power here, times n, and x times your x here, subtract 1 from the power. This is what we mean by differentiation. This is just the easiest way. So when you see a question under it, this is the way to answer it. Basically, in differentiation, this particular way, we call it general principle. We call it general principle. General principle. So we have different ways at which we can solve this particular question under differentiation. But the easiest way to solve this is what we refer to as our general principle. So when you see a question under a differentiation, just make use of a general principle, get your answer, and then scroll up, solve your questions. You're good to go. So why waste time? When you have a general principle, you're now looking for another way to do it. No, don't try that. That's not allowed. So follow me. We have what? General principle. So let me give you some questions under it, and then we make use of our general principle. Permit me to clean my. You have a question like this. You have y equals to 3x squared plus 2x plus 1. 2x plus 1. This is a question. How do you differentiate this? The y ds is going to be equals to this. You multiply what you have here times this. That's what is going to give you 6x. Subtract 1 from the power. That's going to be 2 minus 1. That is what? 1. That is x to the power 1. That is tx plus 1 plus 2. This is x to the power what? 1 minus 1. Plus this is a constant. This is going to give you 0. So I'm going to explain the basis of a constant to you. Just follow me. This is going to give you 6s plus 2 to the power 0 is what? 1. So that is 2. So your dy ds is going to be equals to 6s plus 2. This is what you're going to get. So let me give you some rules under differentiation. So I'm now going to solve some more questions for you on how to answer questions on differentiation. Rules of differentiation. Rules in differentiation. Rules in differentiation. Differentiation. So what are some of the rules in differentiation? Now the first thing is that if you have a constant, the differential of a constant is equals to 0. What do I mean? 1. The differential, let's say d with respect to c, is equals to 0. Your c is what we mean by constant. What do we mean by constant? Constant is what does not have a function of x with it. That's what we mean by constant. So if it does not have a function with respect to what you are differentiating to, then it is what we say it is what? A constant. So and the differential of a constant will always be equals to 0. That's the first thing you need to have at the back of your mind. So the second thing is, number 2 is the differential of af of x. That is, so it's going to give you a the differential of ds of f of x. What does this mean? This means that when you have a number and that particular number, so let me give you a condition that's actually where a is constant. Where a is constant. Constant means it can be a value, it can be a number, but constant means that it is not a particular, it is not attached with respect to x at which you are told to do. Now check this. They said d dx of a f of x. Now f of x means the function with respect to x. That's the meaning of f of x. And we said our a is a constant. So when you have a constant multiplied by a function, that has the x with respect to it. So the constant is still going to remain there, but what you are going to differentiate is going to be your function that has x in it. That's what you are going to differentiate. So the third one is when you have d ds of u plus v plus dot 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 dot. That is plus a lot of things. So it's going to give you d ds, that is the u, plus dv ds plus dot 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 dot. What does it mean? This means that if you are told to differentiate a particular function, that we are given a function, and now note that those functions are with respect to x, right? A particular function separately, this function plus this function plus this function plus this function. If you are now told to differentiate it, that means you are going to differentiate each of those functions. You differentiate each of those functions with respect to x. That's how we are going to differentiate. I'm just going to give you an example. Just follow my sign. Take you on that journey. So the fourth one, number 4, is going to be equal to what? When you have d dx of u dot v. Now note, when you have this means that u is a function of x, and so this is going to give you u dv ds plus v du ds. This is the meaning. So when you have two functions, the condition for this is that when you have two functions, u and v, those are two functions. Now u is a function with respect to x multiplied by a function v with respect to x also. So when you are multiplying those functions together and you are now told to differentiate those functions, now mostly this function might be function that you might not be able to either multiply together, or it might be a number with a higher power. So what you do is that just make use of this rule. Pick the first one, differentiate the second one, plus pick the second one, differentiate the first one. That's how to navigate through it. So we're going to solve more questions on that. So another one is when you have d ds of u over v is going to give you v du ds minus u dv ds over v squared. That means we have d ds of u over v when you have a function divided by another function. So it's going to be what? The function that you have under multiplied by, you differentiate the function that you have up, minus the function that you have up, differentiate the one that you have down. Is it everything divided by the function that you have down, just square it. That is what that rule says. And then the last one I'm going to tell you, which is what we regard as function of function. So I'm going to tell you the name of each of those function. When you have, so that is this one with dy ds is going to be equal to dy dz, this dy dz times the z ds. So let me tell you the name of these functions. For this is a constant. This is constant. This is a function with respect to constant. This one is a function with respect to that has another constant. Now this one is a normal function, but when you get to this is what we get to as product rule. We have what we call product rule. This product rule. This one is what we regard to as quotient rule. And this one is what we regard to as chain rule, or we call it function of function. Chain rule, or we regard to it as function of function. So these are the rules attached to differentiation. So follow me as I solve some questions on differentiation for you.